Okay, so there's three kinds of a line that you're going to have to know. Standard equation, slope-intercept, and then there's this one. And that's the one I think that you probably haven't got much experience with. In my little Centio poll that I did in my other class, I found it was about a 70-30 ratio on kids that already knew this and were pretty good at it, and others that felt like they'd never seen it before. Okay? Now I want to get you guys to do the Centio too, and so we're going to take a second to set that up, and then get a poll from you on whether or not you know this point slope form or not. So grab your little Centio units. All right, so now we're going to try a couple examples of changing between forms. This is one form. What form is it in right now? Standard. And I want you to change it to slope-intercept. That basically just means get it to be one of those y equals things. So solve it for y. Go ahead and do that right now in your notes. All right, your first step is get rid of that 3x. Now, you don't have to show this. I'm going to write it in green. It's optional to write that, but you have to have this next part. The 3x and the minus 3x cancel. So I'd have negative 4y equals negative 3x plus 8. Notice I put the x in front. I could have said 8 minus 3x, but the x's there got to be in the right after the equal sign. So next I got to divide by negative 4 everywhere. Again, ideal world, if you had tons of space and everything, you'd divide by 4 on each spot, or negative 4, and then you don't have to show that. You do have to show this. Y equals, and the negative 3 and the negative 4 cancel to make positive 3/4 x minus 2. One common thing people forget, like over a summer, is that when you are dividing by 4, you don't just do it to each side, you do it to everything. Unlike if when you're adding like 5, you don't add 5 to everything, you add 1 on each side. When you're multiplying or dividing, you do it to everything. All right, raise your hand if you had 3/4 x minus 2. Good. Moving on. Oh, that went 2 slides at once. You know what? We don't need to do another one of those. This would just be change it to slope-intercept. You just get the y alone. Piece of cake. All right, what we do need practice on is that other kind. Y minus y sub 1 equals m times x minus x sub 1. That form has got a point here and here and a slope here. For those of you that were in that 20%, that hadn't done this before, this is the notes I would take on it. Point goes in those two spots, and the slope is where m is. So, for those of you that have done it before, you should be able to if I say 5, 2, and slope is 11, you should be able to write me an equation for it, like bam. If you haven't seen it before, I'll show you how this works in a second. There's the equation with the point and the slope taken out. And the point goes in here and here, and it's the x and the y of it. The x is 5, and the y is 2, and the slope is 11, goes there. Raise your hand if you had that one right. All right, good. So most of you get that. It's a piece of cake. You just stick in the point here and the slope here. The only way it can get tricky is what if I had made this negative 5? Well, and I'd have to put in a negative 5 here. And then I'd have a negative negative, which would make that positive. All right. The calc teachers really like this form. So we're trying to get you ready for that down the road. We use this form almost as much. In fact, I think they say in calc they use it more than this, the slope-intercept form. They use this form a lot. Okay, so we need to make sure you get that. All right, moving on. Graphing linear equations. What if you're graphing something that only has one variable, like y, but this is an xy chart? My advice is just to find the spot that you know it works, like y is negative 3. Well, that's right there. And now you just have to figure out where does it go from there. It either has to go like somewhere, has to either go up and down or left and right, or it has to go at some kind of an angle. But this doesn't have any slope or anything. So if it has no slope, that's not the same as a slope of 0. Or is it the same as the slope of 0? All right. Well, it either goes this way or it goes this way. And I'll ask this question. I think it'll become really clear. If you know this is -3, is this a spot where y is -3? Then I can't go up and down, can I? I have to go left and right. So there's how it looks. You will forget, if you're normal, which way the x ones go and which way the y ones go. But you have to be able to like sort it out by just reasoning. All right, here you divide by 2 in both, then you'd have x equals 5. And then if I find x is 5, I'd write 1, 2, 3, 4, 5 right there. And then again, I either go up and down or I go left and right. And in this case, where is x 5? Is this a spot where x is also 5? X is also 5 there. Yes, it is. So this kind goes like that. All right. So you just kind of reason it out. When there's y equals x, you got both variables in it. Now it's going to be a line that doesn't go up and down or left and right. It's going to be a line that, in this case, has a y-intercept of 0 and a slope of 1/2. The y-intercept is 0. Slope is 1/2, means rise 1, run 2. Rise 1, run 2. There we go. Here's the equation for that one. This one, I can either solve it for y and do the same thing I just did a second ago, or there's another way I want to show you. This way is really powerful because it's a way that works on every problem. It's handy. Like even in really hard problems on the SAT test, if they asked you which is the right graph for this, and you didn't even know how to put it into your calculator, you could always make an XY chart. It always works. On easy ones, on hard ones, on things that are in different forms, it always works. All right, so if I have an XY chart, I'm just trying to find a combo of X and Y that will make this work. Somebody give me one. If X was this and Y was this, it would work. Yes. If X was 0 and Y was 2, I'm going to double check you. 2 times 0 is 0, and 3 times 2 is 6. 0 plus 6 makes 6. You got it. So 0, 2 is one combo. Got another one. X is 3, Y is 0. I'm going to double check you. If I stick in a 3 here and a 0 there, 2 times 3 is 6. 3 times 0 is 0. Perfect. And there's got to be one other point at least. When we ask you to graph, technically it only takes 2 points to make a line. But just think about how dumb it would be if you graph only 2 points. If your life depended on this answer, you can't really tell if you're right. But if I got 3 points that all line up perfectly, it'd be like, oh, okay, I got to be doing it right because all 3 were in a straight line. Whereas if you have 2 points, you can't tell. If I just move this other point over here, it looks like it's right, but I can't tell. You know, I can't tell if it's right or not. So you have 3 points. So let's do one more point. And in this case, you might be thinking, well, those are all the easy ones. It is. But maybe if we use something different. Yes? 2 times 6 is 12. And this is negative 2. So 2 times 6 is 12 plus negative 6 would make 6. Very nice. 6 and negative 2. So now I can graph them and see if they're all in a straight line. Over 0 up 2. Over 3 up 0. And over 6 and down 2. Does it look like they're lining up in a straight line? Yep. All right. So that technique of graphing is something I know you learned a long time ago, but bring it back. It works on every graph. So if you get stuck on a tricky one, have a good day. Oh, wait. You want one of these worksheet for today. That way you don't have to print it off of Schoology. All right. Graphing linear equations that are a little more complicated. The only thing here is that we don't have it in y equals form again. You can always do that if you want. Solve it for y, and then you know the y-intercept and the slope. But if you're smart enough, you can tell a point. And what else can you tell from this? The slope. So if I know that the point is at, is it 4 or negative 4? And is it 2 or negative 2? That's my point. It's negative 4. And positive 2. See, the standard form has a negative here and here. You get what I'm saying? In the normal form of it, it's y minus y sub 1 equals m times x minus x sub 1. So if it has a negative here, that's normal form, and so you just take whatever number is there. If there's not a, if the number is not a minus, oh, why is everything moving? If the number, what? Stop that. Okay, there we go. If the number is not minus, if it's a plus, then you got to use the opposite of it. Okay, so there's my point, and there's my slope. And so I have negative 4, 2, and the slope is 3. Rise 3, run 1. Rise 3, run 1. There we go. Okay. All right, so there is another way you can graph these. In this way, you could use an XY chart, or you could solve it for Y. All right, I don't think we need to do more practice on that. You look like you're handling it just fine. All right, I'd like to do one like this. It's just normal equation solving. It's just getting the X alone. It's just that it's kind of intense because there's a lot of little parts. It'll separate out the careful people from the not careful people. All right, so I'd like you to do this one just on normal paper, and then in a second I'm going to put up the question and have you type in your answer as a decimal on the calculator. Okay, the answer is a decimal, like 2.7 or whatever. All right, so go ahead and solve that puppy. Okay, I've enabled your CentOS to be able to handle the answer. So once you got the answer, type it in as a decimal, and then hit enter. And then I think it's going to tell you right on your CentOS unit whether you did it right or not. Let me know if it does. I'm curious. It doesn't? Okay, I guess it's going to wait till I hit stop. I can fix that for future. I'm looking at my results preview. I don't think people at home can see it on the video, but there's one answer that about half of you are getting, and the other half are getting it wrong. Oh, look at that. Well, there's two answers that are, oh, I think I know what's going on. It was half the people that hadn't answered. Forget that. But still, it's coming out to like one main answer that most people are getting, and that probably is the right one. As soon as I hit stop, it'll tell me. I think the 26% is the people that haven't answered. The green or the teal section there is what percent of kids haven't answered yet. Because that keeps shrinking. That makes sense. So I'm up to 21 out of 27 of you have answered. Some of you guys might think you answered, but you haven't actually hit finish yet. Is it finish or enter, or what does it say on there? Just enter a couple times? Okay. On to 14% of you have not entered. Basically, that's 3 kids. I'm getting close. Down to just 2 people. And if you could see this, there we go. All students have answered. I don't know if I can drag this out. Whether the video can see it, I guess not. Okay. So I can now hit stop this assessment. And there we go. It's official that, man, we had a lot of different answers. Holy smokes. That's crazy. We had 44% of you have the correct answer, which is 3.5. Now, I know some of you are like, okay, I swear I did the thing right, and I didn't get 3.5. How many of you said 3.5? Just raise your hand. All right, so yeah, it's matching up with what the machine says. About 44% of you had it right. Neighborhood of half. Okay, so where are common places that you could screw up? Or is it possible that the key is wrong? We'll find out after this. Yes? Yep. You'd have 6x plus 30 minus 15x plus 10. That's a very common place to screw up because people will see the minus and they'll put a minus, but it's a negative 5 times a negative 2 makes a positive 10. Did I catch anybody? Is that where your mistake was? Anybody? I got a couple people, all right. Equals x plus 5. Ah, okay. So right now what I should be doing is putting these together, right? Which makes negative 9x and positive 40 equals x plus 5. And you're thinking maybe some people subtracted 5 right now? Because you're right, I was talking about that yesterday. The smart thing to do is to get rid of one of these two first, not to mess with the 5 or the 40. All right, so the next thing I would do, would you think it'd be smarter to get rid of the negative 9x or to get rid of the x? The negative 9, because it can get rid of a negative. That's a good thing. So I'm going to add 9x to both sides. And I'll have 40 equals 10x plus 5. And then I just have to get rid of the 5. So I go minus 5 on both sides. And I have 35 equals 10x. And then I divide by 10 on both sides. And I get 3.5. Okay? You get that the 3.5 is the right answer? All right. So I'm curious, some people that are not afraid to explain, tell me where you made your mistake. Because half of you made a mistake, more than half, 50, 60%. So tell me where the other mistakes were. One kid told me. Want to tell me? Oh, I thought that was a hand. I'm sorry. Okay. But tell me. Ah, okay. All right. So when you tried to move that 5 and you like added it somewhere?
Yeah, it's like.
Gotcha. So you probably had a 45 instead of a 35? I gotcha. And then a 4.5 was probably your answer? All right. Any other people willing to share what their mistake was? All right. It is one of the most important things is to be able to know where you screwed up. Because if you know where you screwed up, then you keep yourself from screwing that up again next time. All right. So anyway, good enough on that. Let's move on. I don't think we need to do a second practice on those, and definitely not a third practice on those. We do need to talk about this. When you're solving equations, you can get a number like we just did, 3.5, right? Or you can sometimes get an answer to an equation which is that nothing will ever work. Let me give you an example. This one right here, number 2, the green one. When you actually do this, it says 5x plus 10 equals 10 plus 5x. Well, it seems pretty obvious. It's the same exact thing, right? If you just solve the normal way, we get rid of the x's to try to get the x's on one side, and you'll end up with getting rid of the x's totally. They'll just disappear. And you have 10 equals 10. What do you do then? The x is not 0. The x is not no solution. Infinite solutions. It's just like this. If I'd have said x equals x, it's the simplest case of that. Is that an equation? Yeah, it's got an equals. Is it true? Yes, x is equal to x. Is there any number that you can put in there that won't work? No, everything will work. That means that everything is a solution. Okay, so this is like saying everything works. That's like saying nothing works. When does that happen? That happens. This is a really complicated case, but it really boils down to just coming out to something like this. X plus 5 is equal to x. Now think about that. Is that ever true? There is no way to ever make that true. So there are equations that do not have an answer. All right? So this one's, when you solve it down, you get rid of the x on both sides, and you'll end up with something like 5 equals 0. It's not true. It never will be true. So this is the kind that has no solutions. You can either write out no solutions, or you can use this, which is the standard symbol for the set of solutions to this problem is empty. It's called the empty set. That's what it really means. So empty set is an okay answer when there's no solutions. It's a lot faster than writing no solutions. Since I know most of us are innately lazy, and we'll rather just slap down a quick symbol instead of writing out no solutions, you can do that. All right? Your homework is right there. Got a fair amount of time to work on it. I'm going to stop the video and hand out the worksheets.